Moving on to the 22nd one. So at 22nd place, we have Dacron. Okay. Now Dacron over here is also known as pteryline, and here the monomers are terephthalic acid. So terephthalic acid looks something like this. C double bond O, OH, and again we have the same repetition on the other side. Okay. So this is known as terephthalic acid, and this terephthalic acid is one monomer and the other one, that is, it is combining with OH, CH2, CH2OH. As you might have guessed, it is ethylene glycol. Ethylene glycol. Okay. Now what happens is that here, which two species will be lost is this OH and this. So both of them will be lost. So there's a loss of water molecule. And what do we get is a polymer which is known as dacron. So dacron will look something like this. So the benzene ring with C, double bond O, and we have O, then again CH2, again a CH2, and now here the O. So this H will be lost because it has at the end. Also the OH here will be lost by other molecules. So they will be involved with other molecules, and here we get our dacron. So n units, because we initially took n units of each of the monomer, and this is known as dacron. Now dacron over here is called a polyester because this particular O is an ester. It is making it an ester because of this O linkage. So it is an ester linkage, and this is known as a polyester. And all it did was lose a water molecule. So this monomer, both of them, lost a water molecule, and we got in return dacron. Okay. So this was the 22nd one. Now moving on to the next one. So next, that is 23rd, we have glyptyl. Now glyptyl over here is also known as alkyd resin. So it is also called alkyd resin, and the monomer that is involved is, okay, so we have COOH over here, and we have got another COOH over here, and this is combining with, now it is very similar to the previous one, that is terephthalic acid, but here we have COOH at ortho and meta position. Okay, there we had at para position. Here it combines with, again with CH2, CH2OH, that is ethylene glycol, and on reaction we get polyester again, and here the polyester looks like this. So we have this, and then they're losing the OH, combining with the glycol, and we get sort of this structure. Here also the same thing occurs. We have got CH2, CH2 again, and an O. So this chain is extending up to far away, and this is a polyester again because it has the ester linkage. Okay, so this one is called glyptyl. Now moving on to the next one, that is the 24th one. The 24th one is called bakelite. So it is called bakelite, and bakelite over here is a copolymer, and it is formed by the combination of, so we have got OH over here, and this is very common to us. This is called phenol. Phenol is combining with HC double bond OH, formaldehyde, the first aldehyde, and these two on combination, the presence of H plus, are giving us what is called bakelite. So bakelite structure is OH, and we have got OH from formaldehyde. Now over time, as the polymerization proceeds, what happens is that the OH comes at all the three positions. So we have them at ortho, meta, and para position, as you can see. Now what happens is, imagine another polymer coming from this side and it having the same thing. Okay, so what happens is that these two will combine, and what will they give? So these linkage will break, and in turn these two will combine with each other. So we have a linkage developing like that, and this in turn is again linked to another polymer which looks something like this. So here we have this chain developing over a long. So this is also a step growth polymer, as you can see, and this is a copolymer, and this forms a 3D structure. Now this will also break, and in turn, so we're talking about the para position one. So this will also break, and in turn it will combine with another. So it will combine, and we will here get a CH2 and a joining. Okay, and also, so here it will combine, this will combine with another one, and as you can see, what we are trying to do is form a 3D structure. So here a 3D structure is being formed, and we are getting this particular caprolactam. Imagine this spreading through a whole distance, and thus it is a very intricate structure, a 3D copolymer, as you can see. Also a step growth polymer. So this was the 24, that is the bakelite. Now moving on to the next one, that is the 25th one. Now here we have a polymer called melamine and formaldehyde. Melamine formaldehyde. Now, melamine formaldehyde over here is consisting of the polymer. So we have got this N, we have got this N again. Please keep seeing the number of N's. That is what is most important over here. And we have this structure developing. Okay, now there are more N, H2 over here, along with NH2 over here. And now we have lone pair on all of them. We know that N is a house of lone pairs, has a lot of lone pairs, and therefore now this one is combining with HC double bond OH. This is what? This is melamine, and this is formaldehyde, of course, and they both are going to form melamine formaldehyde. So now in combination, now we are going to react them the presence of H plus. So what we have to learn before this is that imagine when an RNH2, so primary amide, is reacting with HC double bond OH. So what happens is when this is reacting, it leads to the formation of a compound which is RNHCH2OH. Okay, so a lot of things happening over here. We have the O changing into an OH and combining of all this H being lost from here. And what happens is that over time, so when this further reacts with, let us say, in the presence of H plus, this further reacts, what happens is there's a loss of water molecule, and we are left with R NHCH2 with a positive charge. Okay, and next we have, along with, so now this combines with again with the primary amide, and here this lone pair will attack on our carbocation, and thus this process keeps on continuing. So what are we trying to do here? We're trying to work out our mechanism for this melamine formaldehyde, and what happens is when both of these combine, so these two combine and will give us a similar structure as we previously discussed. And what is it? It is looking something like this. So we have an N over here. This is melamine that we discussed previously, and it has three bonds over here. Now it had an NH2 over here, an NH2 over here, and an NH2 over here. Now what happens is, as we previously saw, this will get attached to a CH2OH. Also, this will get attached to a CH2OH. Also, this will get attached to a CH2OH. Now, over time again, what happens is CH2OH, the bottom one, loses its OH and in turn again combine with another NH, and this NH is belonging to another melamine. Imagine a melamine over here. So this process is continuing, and due to this continuation, we are getting a polymer. So imagine here is a melamine, okay, and this is combining. So there's a lot of combination, and this chain is extending again. So we're getting a copolymer that is being formed between melamine and formaldehyde called melamine formaldehyde. Okay, now